Okay, we are going to finish up section 2 with periodic functions. I apologize for not being there, you guys. Hopefully this will help. Please email me with questions. I can create videos or post notes along the way. We're going to do the best we can while I'm out. All right, periodic function. A function is periodic if there exists a positive number, number p, such that f of t plus p equals f of t. We've seen that in looking at um, coterminal angles. And what we're looking at specifically are all of these functions, sines, cosines, and tangents, are periodic. Sines and cosines repeat every 2 pi. Tangents repeat every pi. So for all number in the domain of f, the smallest positive number p for which f is periodic is called the period of f. We define that now as the sine of t plus 2 pi is equal to the sine of t. Now we know that because if we look at our unit circle, okay, and let's take pi over 3 as our example. We know that the ordered pair here at pi over 3 is 1/2 comma root 3 over 2. And we know then that if I add pi over 3 plus 2 pi, I'm going to get pi over 3 plus 6 pi over 3, correct? Which is equal to 7 pi over 3. That's the same location here. 7 pi over 3. That's just another turn around the unit circle. So we can add or subtract. We can do the same thing by going the other way. If I went this direction, we would have another coterminal angle, and that would be subtracting 2 pi from it. And we know that the sine, which sine of pi over 3 is your y value, which is root 3 over 2. The sine of 7 pi over 3 is equal to root 3 over 2. It's the y value still, right? We can go around the other way, and that would be the sine of negative 5 pi over 3. That would also be root 3 over 2. So those all start and end in the same place. They're coterminal angles is another way of looking at it. But it's the periodic function is what we're gonna call it. The same is true for cosine. If you add or subtract 2 pi from it, you're going to end up in the same place, and you'll end up with the same answer. Tangent and cotangent are the same thing, only their period for this one is pi, not 2 pi. So that just means that in our unit circle, that how do we want to say this? This is let's put that here. This is pi over 3. Down here, this is 4 pi over 3, right? Because I know that if pi over 3 plus pi, or pi over 3 plus 3 pi over 3, that's just going to equal 4 pi over 3. That's how I get that, right? That was our period. We added pi to that. The ordered pair here is, again, 1/2 comma root 3 over 2. Down here, the ordered pair is negative 1/2 comma, negative root 3 over 2. And again, if I find the tangent of pi over 3, right, that's going to be root 3 over 2 divided by 1/2, which is equal to root 3. Or if I find the tangent, if I add pi to that, right, and get the tangent of 4 pi over 3, and this is, remember, this is tangent, this is the tangent of pi over 3 plus pi, right, right there, plus pi. 4 pi over 3 is going to be negative root 3 over 2 divided by negative 1/2. The negatives cancel, and we end up with root 3. And we can do this with every angle, every angle. They're periodic. Okay, so find the values of each of the trig functions. Okay, and what happened here is if I subtract um, well, in this case, they're just looking for um, the answers. They're not actually looking for a periodic. Well, it is. Okay, so cotangent, this period here is pi, right? I know that if I take 5 pi over 4 and I subtract pi, which is 4 pi over 4, I'm going to get pi over 4. Okay, I know that the cotangent of 4, I'm sorry, pi over 4, where's my eraser? I guess we're going to erase it all, aren't we? All right. This is equal to pi over 4. If I find the cotangent of pi over 4, remember our ordered pair of pi over 4 is root 2 over 2 comma root 2 over 2. So x over y is just going to be 1, isn't it? Therefore, our cotangent of 5 pi over 4 is also equal to 1 because they're periodic functions of each other. All right, for part B here, okay, negative 9 pi over 4. If I add plus 8 pi over 4, in other words, 2 pi is equal to 8 pi over 4. So if I add that, I'm going to get a negative pi over 4, right? Those are coterminal. Those are periodic because they're within plus or minus 2 pi of each other. I should be able to find the cosine of negative pi over 4. And we know the negative, if you look at your unit circle rotating in a negative direction, your cosine at pi over 4 is going to equal root 2 over 2. Therefore, the cosine of negative 9 pi over 4 is also equal to root 2 over 2. Hopefully that makes some sense, you guys. You're looking for coterminal angles. It's just another way of looking at it. These functions are periodic and the answers will repeat. Repetitive behavior of all these functions, and it doesn't just have to be 2 pi for sine, it can be a multiple of 2 pi. It could have been the sine of pi over 3 plus any number for n, right? It could have been 2 pi times 4, something like that, and it would equal to the sine of pi over 3. if you're adding or subtracting any multiple of the period, we're going to get the same answer. Same is true for cosine, tangent, cotangent. Um, all right. So lastly, we need you guys to use a calculator, and with that calculator, you gotta have to first find um, your mode that you're in. Both of these are in radian mode, right? Radian, radian measure. So on your calculator, if you find the mode button, you can go down and make sure that your calculator is highlighted mode. Okay, and then you simply hit sine, and then pi divided by 4. And when you plug that in, you're going to end up with point, it says 4 decimal places, 7071. That's for part A. For part B, there is no cosecant function, but we know that this would be 1 over the sine of 1.5, 1.5, right? So 1 divided by the sine of 1.5, and these are radians, and that's going to end up being 4 decimal places, go 1.0025 as our solution. So the next question is there anything you can't put into the calculator and find? If you change to degrees, you can do the same thing. Need you guys to play around with that a little bit. Good luck on homework. You guys email me questions from the previous night's homework if you have them.